Hey Lex. Okay, sorry about the last one. I'm going to do the same kind of comparative example that I did last time. And so I'm going to do the easy version first, because again, if I gave you this problem, uh, I don't think you'd find it too hard. You would know that it's going to be x minus 4 times x minus 1, because you know that there are two numbers that multiply to positive 4 and add to negative 5 at the same time. So x would equal 4 and 1. Okay? So again, I'm going to kind of refer back to this problem because hopefully you'll be able to make the connection here that in order for something to be factorable when it's a trinomial, a couple things need to be true. The first thing is that the two numbers need to kind of add to, rather multiply to the end and somehow add up to the center. The second thing is that the exponent that's in on the leading term needs to be double the middle exponent. So since we have a 2, and technically since we don't have anything there in front of the middle term x, it's technically a 1. So a 2-1 relationship, it's factorable, probably. Well, anyway, the thing that you need to make a connection with this problem is that regardless of what's happening here, you have a thing being squared minus 5 times that exact same thing, and then plus a regular constant term out here. Same thing is happening with this problem. I have a thing being squared minus 5 times a thing, and then just a regular constant. Well, that thing happened to be x inside this problem. When we look at this problem, what I'm going to do is I'm going to go ahead and factor this out, but the thing that's being factored here, and I'm actually going to draw a couple of hard brackets so that we can differentiate our brackets. The thing that's being factored is actually going to be x plus 3. Okay, and then that's going to go in here, x plus 3. And now all I need are two numbers that multiply to this 4 and then add to negative 5. Well, that's the same thing as on the right side here. This is going to be minus 4 and then minus 1. So from here I can go in, and let's not forget all this equals 0. So now we can go ahead and simplify this. This is really x minus 3 minus 4. That's really x minus 1 equals 0. And then this here is x plus 2 equals 0. So what we get is we get x equals 1 and x equals negative 2. Wow, that was odd. I can't believe I did that wrong that one time. Okay, so let's go ahead and let's take a look at number 1b. So we've got 2x minus 1 squared minus 5 times 2x minus 1 plus 4 equals 0. So with this one, again, I'm going to go ahead and just separate things out. Oops, not that color. I want this one. So again, I have a thing being squared minus 5 times the same thing plus 4. And again, the biggest issue with this is that they're just trying to get you to factor more complicated things. When you get into trigonometry and logarithms, you're going to have to factor out more complicated things, and they're just trying to get you used to that. So let me go ahead and just make a real quick similar problem here. If I said this was, say, k squared minus 5k plus 4, hey, this is the same problem as the last one, equals 0. Again, you wouldn't think twice. It'd be k minus 1 times k minus 4 equals 0, so k would equal 1 and 4. Well, here we can go ahead and just substitute the k's in if you really wanted to. I don't know what your teacher told you to do, but I'm going to go ahead and just kind of make my two hard brackets here. And again, since the same thing is being squared here, that is the center term, we can go and separate that out. I'm going to take one each, so it's going to be 2x minus 1 and then 2x minus 1. Now again, I need two numbers that multiply to 4 and add to negative 5. Well, that's the same as the last problem, so it's negative 1 and negative 4. So let's go ahead and combine our like terms here. This is 2x minus 2 equals 0. This is 2x minus 5 equals 0, right? I just combined these two, combined those two. So when you Move this over, you're going to get 2x equals 2 and x equals 1. Here you're going to get 2x equals 5 and x equals 5 over 2. Okay, let's try, whoops, we're not going to try anything. We're going to clear some of this junk off. Alright, so let's try number 1c. Let's see what that looks like. And again, you're just factoring kind of more complicated looking stuff. So C is actually something a little bit more akin to what you're used to. And I think the reason why they keep the coefficients and the leading terms, the coefficients the same, is because they want you to get used to this idea of being able to factor various things. And so here we've got the same relationship, a 4 and a 2, which means we've got double, then half, we're good, we're factorable. So I'm going to go and factor this normally, except here, in fact, before I even get to this, what I want to do is I want to change this leading term into something that I can recognize. Well, I need to create something being squared, because that's something that we're more used to seeing. Well, how can I create an x to the fourth as something squared? Well, I can create that using an x squared here, because x squared squared is x to the fourth. And now I can go ahead and create my brackets. Inside each leading term is going to be what's inside the parentheses, so that's an x squared. So that's similar to the other problems. In fact, I think this one's a little easier. It's going to be minus 1 and minus 4, just like it always has been. This is x squared minus 1 equals 0, x squared minus 4 equals 0. And I've got x squared equals 1 and x squared equals 4. I'm going to take the square roots of both sides. So I get x equals plus or minus 1 for the left and x equals plus or minus 2 for the right. Hang on, my roommate just came home. Hold on for 1 second. All right, Lex, here comes number 3a. So we have 2 times this crazy thing squared plus 5 times the same crazy thing minus 3. So let's go and just put this into something that we kind of understand. If I said 2k squared plus 5k minus 3 equals 0, well, again, you probably wouldn't think twice as to how to solve this thing. This is 2k and k. If you remember from my class, I told you not to put the symbols in when this final one's negative, so let's just mess with some stuff a little bit. I'm going to put a 1 here and a 3 here. I'm going to check. That creates a 6. This creates a 1. A 6 and a 1 can create a 5 as long as the 6 was positive and the 1 was negative, right? Because we're trying to create a positive 5. So here, why don't I just go ahead and replace all the k's with this crazy thing? So I'm going to say 2 times the crazy thing minus 1 times the crazy thing plus 3 equals 0. So now we have to go ahead and solve this thing. Now this is going to be a little tricky. If I say 2 times 1 over 2y minus 1 equals 0, and then 1 over 2y plus 3 equals 0, we have a couple of ways we can solve this. Well, the good thing is that the 2's here are going to cancel each other out. So I've got 1 over y minus 1 equals 0. Well, I'm going to add 1 to both sides, so I've got 1 over y equals 1. If I multiply both sides by y, scroll down a little bit here, those are going to cancel. I get 1 equals 1 times y is y. We're done. I'm going to do this one a little faster. This is 1 over 2y equals negative 3. Multiply both sides by 2y. So I get 1 equals negative 6y. Y equals negative 1 over 6. So sometimes people do like to do this substitution property where they just kind of rewrite it into something that they do know, and then they just kind of, replace all the k's, or sometimes people call it a u substitution. I don't know. I find u substitution to be, not to sound like a mathematical elitist, but that's something that we reserve for. U is a very special letter we tend to reserve for calculus for u substitution during integration. But anyway, that's neither here nor there. So anyway, 3b is 2 parentheses y squared minus 4 squared plus 5 times y squared minus 4 minus 3 equals 0. Okay, again, let's write this into something that we already know. So why don't we say let k equal y squared minus 4. So what I'm going to do is I'm going to say 2k squared plus 5k minus 3 equals 0. Right, I've just let k equal this y squared minus 4. So again, you wouldn't think twice about how to factor this thing. It would be 2k minus 1 times k plus 3. Okay? So now let's just go ahead and do this. You know, we let k equal the crazy thing, so I'm going to say bracket 2 times the crazy thing. So that would be y squared minus 4 minus 1. Oops, keep that in there. Times another bracket. We'll go the crazy thing, y squared minus 4 plus 3. Okay, so from here, there's a little bit more junk going on in here, so I'm going to go ahead and do this a little bit faster. It's going to be 2y squared minus 8 minus 1, so that is 2y squared minus 9 equals 0. And then here I have y squared minus 1 equals 0. I have to really hand it to textbook writers. They really do a good job making numbers come out clean. 2y squared equals 9. Y squared equals 9 over 2. Sorry, I had to just make sure I wrote the problem down correctly. Y is going to equal, when I take the square root of both sides, I'm going to get a plus or minus. This is 3 up top over rad 2. Now, I don't know if your teacher wants you to rationalize the denominator. Sometimes it's important, sometimes it's not. So what you get is y equals positive or negative root 3 over 2. Hey, that number is going to be something that you're going to start to memorize after a while. But that's at a later time. Y squared equals 1. Y equals plus or minus 1. And you're done with that problem. All right. Let's do something a little more challenging while I find it. Hold on, I'm going to pause real quick. Hey Lex, here comes 3C. Now the reason why I chose this one is because this one's a little odd. Like, you've got these negative exponents going on here, but I want to show you that this problem is no different than anything that you have dealt with already. So what I'm going to do is I'm going to create a 2 out here, and this is going to be something squared, plus 5 times y to the negative 1 minus 3 equals 0. Now I have to try to create a negative 2 here using the same value. So hopefully it makes sense. I'm going to make this y to the negative 1. Now, whenever you do a quadratic technique like this, like I did here, like I'm about to do number 5's a and b, 7 a and b, and number 9, you always want to make sure that the leading term with its exponent matches the second one. Right? I've got a y to the negative 1 here and a y to the negative 1 here. We're all good. So now it really just becomes 2y to the negative 1, just like that problem we did, plus 1, and then y to the negative 1, not plus, I'm sorry, plus 3. Okay, and I'm sorry, this needs to be minus 1. Minus 1 equals 0. So what I've got here now is 2y to the negative 1 minus 1 equals 0, and then y to the negative 1 plus 3 equals 0. So what I'm going to do here is I'm going to add 1 and divide by 2, so y to the negative 1 equals 1/2. And so y to the negative 1 is really 1 over, excuse me, y to the negative 1 is really 1 over y equals 1/2. So I'm just going to flip both of them, so y equals 2. Right? I just moved this up, and if I moved that up here, I'm going to move it up here. This is y to the negative 1 equals negative 3. So really, 1 over y equals negative 3 over 1, which means y equals negative 1/3. All right? Let's see here. Number 5a. So x to the 4th minus 3x squared minus 4 equals 0. Okay, this one's not that bad. We know that it's going to factor out in terms of x squared and x squared. All right, that should be a piece of cake. Let's see here. Two numbers that multiply to negative 4 and add to 3, so that's negative 4 and positive 1. So from here, I'm going to go ahead and set each one equal to 0. So you get x squared equals 4, x equals plus or minus 2. And then here you get x squared equals negative 1, x equals plus or minus I. Okay, I'm starting to move a little bit faster. Hopefully it's not bothering you too much. Okay, I like this problem right here. X minus 3 rad x minus 4 equals 0. I really like this book, actually. It's much better than the book that we have at my school. Anyway, I'm going to go ahead and state why this is probably a confusing problem. It's because of this rad x right here. But this rad x can be rewritten as 3x to the 1/2. And so we still have that same ratio, 1, 1/2, 0, so we still got a factorable thing going on here. And if it ever helps, I'm going to go and use this method again. Something squared minus 3x to the 1/2 minus 4 equals 0. And so remember, if at very best, if you don't remember how to do this, just remember that the inside needs to match this middle term. But if you want to check, 1/2 times 2 using our rules of exponents does equal 1. So x to the 1/2 squared really is x. So now we're going to go and factor this thing like we always have. This is x to the 1/2, x to the 1/2, and I've got a 4 and a 1. Looks like I'm trying to create a negative 3, so here and here. Okay, so I've got x to the 1/2 minus 4 equals 0, and x to the 1/2 plus 1 equals 0. So here, x to the 1/2 equals 4, and in order for me to get rid of this 1/2, I'm going to raise everything to the second power. Those are going to cancel each other out, so I got x equals 16. Now, before you jump the gun on this problem here, I want to show you something. I'm going to go ahead and subtract 1 from both sides, and x to the 1/2 equals negative 1. Now, I'm going to rewrite this because x to the 1/2 really is, in fact, the square root of x, and that equals negative 1. Now, most people at this point would probably square both sides and say x equals 1, but the problem is you got to think for a little bit. When is it ever possible to take the square root of a number and receive a negative number? Well, let's see. It's the square root of 1, that's 1. The square root of negative 1, well, that's I. Is there any number that I can take that will allow me to get a negative 1 here? No, there isn't. So this problem, or this side of the problem, shouldn't even exist. Your only answer is x equals 16. All right? Let's do a couple more. Let's do a couple more here. 7a should be a piece of cake. Let's do 7b. X to the negative 4 plus 5, x to the negative 2 minus 36 equals 0. Okay, so let's go ahead and just switch this down. Something squared plus 5, x to the negative 2 minus 36 equals 0. Whoa, this thing's starting to bug out. So this should be x to the negative 2, all right, because negative 2 times 2 is negative 4. Let's go and factor this normally. So x to the negative 2, x to the negative 2. I need two numbers that multiply to 36 and add to 5, so that's going to be plus 9 minus 4. So what I've got is x to the negative 2 plus 9 equals 0, and x to the negative 2 minus 4 equals 0. So let's go ahead and do this problem here. X to the negative 2 equals negative 9. So that's like saying 1 over x squared equals negative 9 over 1. I'll go and flip both sides here. So I've got x squared equals negative 1 over 9. I will take the square root of both. So I've got x equals plus or minus I over 3. Okay. Actually, I'm going to slow that down for you. I'll do that part one more time. Remember, when you take the square root of a fraction, it's the square root of the top over the square root of the bottom. The square root of negative 1 is I. The square root of 9 is 3. And don't forget, it's an equation, so it's plus or minus. Let's add 4 to both sides here. So x to the negative 2 equals 4. So 1 over x squared equals 4 over 1. X squared equals 1 over 4. Take the square root of both sides, so you get x equals plus or minus 1/2. Okay, hopefully that is helping. Let's see, that was 7b, so let's 9. X minus 11 rad x plus 30 equals 0. So again, rewrite this rad x into negative 11 x to the 1/2 plus 30 equals 0. And you got an x right here. So again, rewrite this x so that it has some kind of incorporation of 1/2 power in it. So it'll be something squared minus 11x to the 1/2 minus 30 equals 0. This is x to the 1/2. And again, if you don't remember, it should just match up with the second term. So we're going to get x to the 1/2, x to the 1/2, two numbers that multiply to negative 30. I'm sorry, whoops, plus 30. Sorry. So that makes it easier, negative 5, negative 6. Awesome. Okay, so x to the 1/2 minus 5 equals 0. X to the 1/2 minus 6 equals 0. So x to the 1/2 equals 5. X equals 25. Right? I just square both sides here. X to the 1/2 equals 6. I'm going to square both sides, so I get x equals 36. Okay, now I'm going to do the bear. The bear is number 13. 1 plus x over 2 quantity squared minus 3 times 1 plus x over 2 equals 18. Okay, so first thing I'm going to do is I'm going to subtract 18 from both sides because I want to get it all equal to 0. So 1 plus x over 2 squared minus 3 times 1 plus x over 2 minus 18 equals 0. So, okay, I'm going to do a comparison because I'm going to show you that you know exactly what to do in this problem. I'm going to say let k equal 1 plus x over 2. So this problem really is k squared minus 3k minus 18 equals 0. Again, if I showed you this, you wouldn't think twice about how to factor it. You would know that this is k, and it's negative 6 and positive 3. So just fill the k's back in with the junk. So now what you've got instead is, I'm going to go ahead and separate our brackets here. You've got junk, which is k, 1 plus x over 2 minus 6 times, let's see here, 1 plus x over 2 plus 3 equals 0. Okay, this problem stinks. 1 plus x over 2 minus 6 equals 0. 1 plus x over 2 plus 3 equals 0. Let's solve the last one first. I think we're going to run out of space here, so let me just go ahead and do some computer stuff here. Okay, move this thing back up. Oops. Okay, so hopefully you've been able to track everything I've done so far. So let's solve the left problem here. I'm going to add 6 to both sides. So I've got 1 plus x over 2 equals 6. Multiply both sides by 2. 1 plus x equals 12. X equals 11. 1 plus x, I'm going to move a little fast, over 2 equals negative 3. 1 plus x equals negative 6. X equals negative 7. 15. Ooh, that's a good problem too. I'll do that for you. I like 15. I must say, your book is a really good one. 2 over y plus 1 over rad y equals 1. So this is really, I'm going to subtract 1 from both sides. So I've got 2 over y plus 1 over rad y minus 1 equals 0. I'm going to go and convert this. This is really 2y to the negative 1 plus y to the negative 1/2 minus 1 equals 0. So now what I'm going to do is I'm going to go ahead and do that one technique that I showed you, and it's going to be 2 parentheses something being squared plus y to the negative 1/2 minus 1 equals 0. Well, again, just match it with the second one. It's negative 1, darn it, that's not enough space. Negative 1/2. Now, if you're not sure, just check. Negative 1/2 times 2 is negative 1, so we really do have the same problem. It's just written in a different way here. So I'm going to say it's 2y to the negative 1/2 times y to the negative 1/2, and that equals 0. Well, it's going to be 1 and 1 because two numbers that multiply to 1 are 1 and 1. I need to find out a way to make a positive y, though, so it's going to be positive here and negative here. So 2y to the negative 1/2 minus 1 equals 0. Y to the negative 1/2 plus 1 equals 0. So what I've got is I've got 2y to the negative 1/2, sorry, I'm getting kind of tired here, equals 1. Divide by 2, so I've got y to the negative 1/2 equals 1 over 2. What this really is, I'm going to back this thing actually over here, is y to the negative 1/2 is 1 over rad y equals 1 over 2. I'm going to flip both sides. So rad y equals 2, so y equals 4. And I know I'm kind of all over the place with this problem. Sorry about that. Okay, this is really 1 over rad y equals negative 1 over 1. I'm going to flip both. I'm going to say rad y equals negative 1. But again, is there anything I can take the square root of to result in a negative number? No, so this whole problem is gone. Okay, Lex, hopefully that's enough. If not, please send me a message. I'm going to be gone all weekend, but I will try to find time Sunday to help you out if this is still giving you trouble. Okay? See ya.